Impacts of Computing and Intro to Programming. Lesson 1.5, Introduction to Programming. Okay, so a program is just a set of instructions that tells a computer what actions to perform. So we have different types of programming languages out there, and each one of them essentially does the same type of stuff. They're just formatted differently. They have different syntax. For this, we will be using pseudocode, so we are not going to adapt to any specific programming language. We're going to focus mainly on the logic and reasoning behind the program. So the algorithm, an algorithm is basically how you go about solving a problem. So it's the sequence of instructions that actually solves a problem you're looking to solve. The three basic building blocks of an algorithm are sequencing, which is the order of steps to ensure correctness, to make sure you're doing what you should. Selection, so these are going to be like if-else statements. So like if this condition is met, do this. Otherwise, do this other thing. So it's basically how we control flow of our program based on conditions. And then iteration, we're going to use loops. Iteration are repeated steps that execute until a condition is met. So for instance, rolling a die, okay, you can either say, I'm going to keep rolling this die until I get a 5. Or you could say, I'm going to roll this die 10 times and count the number of times I get a 5. Those would be examples of iteration. So we have different levels of the language. So basically what we typically as programmers program in are high-level languages. So this is what we use. This is your actual programming language. So it's very similar to what we would do in a human language. It's easy to read and follow. And the code can actually be ported to different operating systems. All right, so for instance, x equals y plus 5. And we have a variable x, it's being assigned the value y plus 5. Now, in the background, what happens to that high-level language that we code, it goes into an assembler. So an assembler basically converts your high-level language into instructions that a specific operating system can use. So this assembly language is when the operating system is like, okay, so how does this operating system work from here to here? All right, so this is where the operating system kicks in. So again, high-level language, operating system independent. It's the programming language we use. Assembly language, this is where your operating system in your computer kicks in. And then all computers only understand what we call a binary code. Okay, binary is just signals on and off. So the assembler interprets the high-level language into operating system specific language and then converts that to machine code. All right, so low-level language, for instance, you got like 1, 0. So notice it's all ones and zeros there. That's machine code. That's the lowest level, and that's what your computer actually understands. So you'll hear some terminology. Some languages are what we call compiled languages, and some languages are interpreted. Some programming languages can actually be both. To compile, compiling a language means it takes the source code, which is the code you write as a programmer, and it runs all of it. It translates all of it into machine code and then runs a program. So basically it takes the source code, creates an object code from it, and a lot of times that object code becomes an executable file. So if you want to port your program to multiple operating systems or multiple computers, compiling is nice because what you do is you compile your language once, it creates this object code, this executable file, and then that executable file can work on any computer. And it never has to be run again. An interpreter, on the other hand, an interpreter does not make an executable. What an interpreter does is it makes machine code line by line. So it's going to run a line of the source code, convert it to machine code, then it's going to go to the next line, do it for the next line. It does not make a one-time process. So because it's interpreted, this does require extra processing time. And it does not run, you can't just run it once and then port it to other computers. You would have to interpret it on each computer that you use. All right, so again, just to recap here, source code is the actual programming script. Okay, so it's like what you type when you write a program that is viewable in a text editor. Object code is when you compile your source code, it creates a compiled output that becomes your executable file. So in order to type source code, you're going to need some kind of editor. Now, you could use a generic, text editor such as Notepad. Okay, so here's Notepad. This is if you wanted to assign x equal to 10 and y equal to 5, you could write those lines. Basically, if you use a text editor, you can't compile or interpret your language in it. You would type up your code and then you would have to copy and paste it into what we call an IDE, which is an integrated development environment, to actually run your code. Okay, so typically we don't just use a text editor. We use an IDE. We use something that will actually help compile or interpret our code. Okay, so let me show you something like that. So just be aware that the programming language that you end up using is going to decide what type of IDE perhaps to use. I'm going to show y'all something. This is Replit. It has it used to be free for education. It's not anymore. But basically you can create a REPL and choose what language you want to work with. I'm going to show y'all this in Python just so you can see how an IDE kind of works, okay? But just understand that IDEs, they don't all look like this. You have to know what language you're typing in. We will not be using this for most of our code because we will be doing pseudocode, which is not an actual programming language. This is just to show you how an IDE kind of works. So here, notice you're still going to be typing the same type of things we were doing in the text editor. Okay, so I have x equals 5. Now notice one thing that's different is I have some line numbers here. So I have like line 1, line 2. That's good so we can reference the lines if we want to. Also notice in gray, I haven't started typing anything. It's suggesting y equals 10. So that is kind of nice because it kind of guides you, especially if you're first learning how to program. It can guide you as to like what it expects. It uses AI to kind of generate like what it expects you to write. Notice the little red squiggly. That red squiggly means there's an error here. This is not a true, this is not a good statement. If I ran this code, it would give me an error. In fact, let me run it real quick. So there's a run button here. And it is going to say, look, invalid syntax. That is a syntax error. We'll talk about errors a little bit more detail later, but that red squiggly means that there's an error here and we need to make sure we fix that. Okay. So, and look, it's going to suggest print x plus y. So let's go ahead and do that. So what this is doing is, the text editor, I could type all this in a text editor, but it's doing so much more. It's suggesting things to me. It's trying to locate when I have errors. It's giving me line numbers. I can run my code here. Okay, so this is going to interpret my code line by line. Up here, there's like really, I don't know, like, let me close that. There's a lot going on here. So any IDE you use should have like a console, which is basically going to show you what it outputs. Notice it outputted the number 15. That's because it printed or outputted 5 plus 10, which is 15. So we can write our code. It helps us write our code. It prints out the output, it runs the code. So an IDE is so much better because we can do it kind of all in one. All right, so going back to the slide, that's just kind of showing you. So a context editor displays the source code, but it cannot compile it. So that was Notepad. An IDE, again, an integrated development environment, is software that contains everything you need to write and test your code. So you have your editor, right, where you can type. Then you can usually run your code. So that's going to either compile or interpret it depending on the language. And the debugger, so it, it kind of, when I ran it with the error, it told me, hey, there's an error here. That's a debugger. So it tries to tell you you have an error and maybe a little information about what your error could be. So it can check syntax is typed. So it can suggest code. That was that gray code. You can run and preview your code. And if you're doing a compiled language, it will create the executable for you. So again, IDEs are great, but you have to know which programming language to use. Since this course is designed for a multitude of teachers, there is no specific language we're going to use. Personally, I use Python a lot just because that tends to be what I teach with data science. But there's Java, there's C++, there's so many languages out there. JavaScript. It's going to just depend on what you teach as to what language you're going to need. All right, so for the praxis, we will be using only pseudocode. Pseudocode is not an actual language. It will define the type, like the logic of the programs, the structure of the programs, but it will not use official programming language. So you will not be able to take what we do and type it into an IDE and run it. Now, as we saw with that example, I got a syntax error because I had y equal nothing. So syntax errors, these are special rules given to your statement. And basically, if you don't follow these rules, you get a syntax error. We saw, y equal, we needed to equal something. We needed it to assign something. Some other common ones, unbalanced parentheses. If you open a parentheses and don't close it, that will cause an error. I had a print. That's a keyword. If I accidentally typed it wrong, it might give me a syntax error. Incorrect punctuation, anything like that can cause a syntax error. Now, runtime errors. Runtime errors are when your code actually will compile or interpret, it'll run, but you get a problem with your code. A lot of times you'll get like infinite loops where your code will not actually stop. It'll just keep going forever. Okay, so that's going to be a big issue. When we talk about loops, we'll talk about how to, be careful of infinite loops. Logic errors. Logic errors are probably one of the hardest ones to notice because your IDE is not going to catch these. A logic error is when the program runs, but it doesn't do what it's supposed to. Like, there are no actual errors as far as the computer is concerned, but it's not right. Okay, it'd be like saying, okay, print 2 plus 2, and you get 7. That's not right. This is usually a programmer error. So this is the incorrect use of an algorithm or incorrect use of math or order of operations. Okay, so this is more human error. And then overflow error. So this occurs with today's computer systems. Our memory is a lot larger than it used to be. But this used to occur a lot when you ran out of storage space. So what would happen is your data would become lost or corrupted. So for example, if you had an old system that only had 8 bits, or that's 1 byte, and you tried to hold something large that had to store it in 9 bits, there wasn't enough bits to store it, you would get an overflow error.